Most tests for Ebola involve extensive ELISA testing. ELISA is an antibody detection technique that requires laboratory equipment and specialized training. The proposed microfluidic device will eliminate the need for training and equipment. The device uses laminar flow and diffusion to separate viral particles from blood for quick sample preparation and detection.
Excuse me, ma'am. Have you been to West Africa lately? Thank you.
So our device operates using both laminar flow and diffusion to separate particles by size. So the way that the device is set up is, at the top here, you load a blood sample that will contain all different ranges in size of particles. And the bottom here, you load a diluent. You flow both the blood sample and the diluent through the device, and both fluids will enter this diffusion chamber. Now the reason why our flow needs to be laminar is so that turbulence and convective forces don't actually transport large particles such as red blood cells into the diluent. However, thanks to Piclet's number, small particles will actually diffuse into the diluent while going through the diffusion chamber, whereas large particles will be left behind in the blood sample because the diffusivity of small particles will be smaller. Because particles, like viral particles such as Ebola, are up to 3 or a couple orders of magnitude smaller in size than large particles like red blood cells. And because of this, the diffusivity of the Ebola particles and the viral particles will be much higher. And we can use Piclet's number from here to design a device that will only diffuse out Ebola and leave the red blood cells and other junk inside our blood behind.
The device utilizes an H filter for particle separation. An H filter is made up of 2 input channels and 2 output channels. The sample flows in through one input channel, and a saline diluent flows in through the second input channel. One output channel leads to a waste chamber, while the other channel leads to a chamber that contains the antibodies that will fluorescently express once bound to the Ebola virus. Pressure differences from embedded syringes will drive the fluid flow. Here you can see laminar flow and diffusion at work. The red fluid will represent the blood sample, while the purple fluid will represent the saline solution. As the fluids meet, they will not mix and will flow in a laminar fashion. The small virus particles will diffuse from the red fluid towards the test chamber, while the large particles, such as the red blood cells and bacteria, will continue on towards the waste chamber. There are 2 chambers connected serially, one for control purposes and one coated with Ebola-specific antibodies. If there is no Ebola virus present, both chambers will look identical, but if Ebola is present, one chamber will fluoresce.
The microfluidic device utilizes particle separation that is mediated by laminar flow and diffusion. In conclusion, this device provides a quick and easy way to detect Ebola.